Paper 2 explained. 1a. The displacement s in meters of a particle t seconds after it passes through the origin is given by the expression s is equal to the natural log of 2 minus e to the power of minus t, where t is greater than or equal to 0. Find an expression for the velocity v of the particle at time t. Well, the velocity is found by differentiating s. So the differential is v equals 1 over the bracket, which is 2 minus e to the minus t, times the differential of the bracket, which is e to the minus t. If you multiply that out, you get v is equal to e to the power of minus t all over 2 minus e to the power of minus t. B. Find an expression for the acceleration a of the particle at time t. Well, the acceleration is equal to the differential of v, which is dv over dt, but because this is a quotient, we're going to let u equal e to the power of minus t and v equal 2 minus e to the power of minus t. So u dash is equal to minus e to the power of minus t, and v dash is equal to e to the power of minus t. The rule for a quotient is equal to v times u dash minus u times v dash all over v squared, which is equal to 2 minus e to the minus t times minus e to the minus t minus e to the minus t times e to the minus t all over 2 minus e to the minus t all squared, which is equal to, if we multiply out the bracket, minus 2e to the minus t plus e to the minus 2t minus e to the minus 2t all over 2 minus e to the minus t squared, which is equal to minus 2e to the minus t all over 2 minus e to the minus t all squared. And part C, find the acceleration of the particle at time t equals 0. So we just substitute t is 0 into the equation, giving us minus 2 e to the 0 over 2 minus e to the power of 0 all squared, which is equal to e to the 0 is 1, so it gives us minus 2 over 1, which is equal to minus 2. 2a. The first three terms of an arithmetic sequence are u1 is equal to 0.3, u2 is equal to 1.5, u3 is equal to 2.7. Find the common difference. Well, the common difference is un minus un minus 1, which is equal to 1.5 minus 0.3, which is equal to 1.2. 2b. Find the 30th term of the sequence. Well, any term in the sequence, un is equal to u1 plus n minus 1 d. So U30 is equal to U1, which is 0.3, plus 30 minus 1 times the common difference, which is 1.2. So U30 is equal to 35.1. And 2C, find the sum of the first 30 terms. Well, S30 is equal to n over 2 U1 plus U30, which is equal to 30 over 2 times U1, which is 0.3, plus U30, which is 35.1, which is equal to 531. Question 3. A sphere has a radius of 22.7 centimeters. A. Find the volume of the sphere, expressing your answer in the form A times 10 to the power of K, where A lies between 1 and 10. Well, the volume of a sphere is equal to 4/3 pi r cubed. So the volume is equal to 4 over 3 times pi times 22.7. Using your calculator, you get the volume is equal to 48996.62, which change into scientific form is equal to 4.90 times 10 to the power of 4 centimeters cubed. The sphere is to be melted down and remolded into the shape of a cone with a height of 19.7 centimeters. Find the radius of the base of the coin to two significant figures. Well, the volume of a cone is equal to 1/3 pi r squared h. And we know that the volume of the cone is equal to the volume of the sphere. Therefore, we know that 1/3 pi r squared, we know the height is 19.7, is equal to 48996.62. Therefore, r squared is equal to 48996.62 times 3, all divided by 19.7 times pi. So r squared is equal to 2375.041906. So r is the square root of 2375.041906. So r is equal to 48.7. So r is equal to 49, to two significant figures. 4a. Let f of x equal 1 divided by x plus 1 plus 2, for x is greater than 1. It must be greater than 1 because we can't have 0 on the bottom. Write down the equation of the horizontal asymptote of the graph f of x. You should all know that any graph of the form 1 over x has a horizontal asymptote at y equals 0. Therefore, because we've added 2, we've gone up 2 spaces, so the horizontal asymptote must be at the point y equals 2. And it does ask for an equation, so you must write down y equals 2. If you're not sure of this, because it's a calculator paper, draw the graph of f of x and see where the horizontal asymptote is. Part B, find f dash of x. So we know that f of x is equal to 1 over x plus 1 plus 2. So f of x is equal to x plus 1 to the minus 1 plus 2. Now we can find f dash of x, which is equal to minus 1, x plus 1, take 1 off the bracket, so we get minus 2. The 2 disappears, so f dash of x is equal to minus 1 over x plus 1 squared. C. Let g of x equal minus a times e to the power of minus x plus b for x is greater than or equal to 1. The graphs of f and g have the same horizontal asymptote. Write down the value of b. Any exponential graph also has a horizontal asymptote at x equals 0. So because it has a horizontal asymptote at y equals 2, b must be equal to 2. So b is 2. Part D. Given that g dash of 1 is equal to minus e, find the value of a. Well, the first thing we have to do is differentiate g. So we know that g of x is equal to minus a e to the minus x plus 2. So g dash of x, differentiate the first part, you get a e to the minus x, the 2 disappears. We're told that g dash 1 is equal to minus e. So we can substitute 1 for x into g dash of x. So therefore, we know that a e to the minus 1 is equal to minus e. Therefore, we've got a times 1 over e to the 1 is equal to minus e. Therefore, rearranging, we get a is equal to minus e squared. Therefore, a is equal to minus 7.39. Therefore, g of x is equal to minus 7.39 e to the minus x plus 2. Part E. There is a value of x for x is between 1 and 4 for which the graphs of f dash of x and g dash of x have the same value. Find the coordinates of this point. In order to do this, use your calculator, draw the graphs of f dash of x and g dash of x between the values of x is 1 and 4, and find any intersection points. Doing this, you will find that x is equal to 1.209 or x is equal to minus 0.205. 5a. The following diagram shows the graph of a function y equals f of x for x between minus 6 and minus 2. The points minus 6, 6 and minus 2, 6 lie on the graph of f of x. There is a minimum point at minus 4, 0. Find the range of f. Well, the range is just what is the output. Well, the output goes from 0 to 6. So we can write the range, which is y, lies between 0 less than or equal to y less than or equal to 6. Question 6. Let f of x equal x squared plus 3 to the power of 7. Part A. Find f dash of x. Well, f dash of x is the differential of a chain, which is equal to 7 times the bracket x squared plus 3. Take 1 from the power, so that's 6, and then times by the differential of the bracket, which is 2x. Multiply 7 by 2x to give us 14x x squared plus 3 to the power of 6. Part B. Find the term in x to the power of 5 in the expansion for f dash of x. So we want the x to the 5th term. In an expansion, we know that every term is n choose r, a to the n minus r times b to the r. In this expression, we know that a is equal to x squared, and we know that b is equal to 3. In this expression, we want n to the minus r, which equals x squared. 6 minus r, we know that because it's raised to the power of 6. Because there is a 14x outside, we want that to equal x to the power of 4, because x to the power of 4 times x will give us x to the power of 5. Because we've got an x squared inside the bracket, the 6 minus r must be equal to 2, because with the powers rules, 2 times 2 will give us 4. So therefore we've got x squared raised to the power of 6 minus 4. So therefore we can now go back. We've got 6 choose 4. X squared raised to the power of 2 times 3 to the power of 4, which is equal to 15 times x to the power of 4 times 81, which is equal to 1215 x to the power of 4. Now to get the x to the power of 5 term, we have 14x times 1215 x to the power of 4. Therefore, we've got 17010 x to the power of 5.